Hi everyone, welcome to this video on mixtures and separation techniques. So this is still C1. Let's jump straight into the definition of a mixture. So a mixture contains different parts, meaning elements or compounds which are not chemically bonded together. So which are not, and that's the key word, not chemically bonded together. So in a mixture, these elements and compounds can be separated. So that's really, really important that you remember this. Mixtures can be separated out into their different elements and compounds. So for example, in a beaker, I might have H2O, I might have, I don't know, I'm just going to throw a few things in there. Argon, I might have nitrogen, I might have CO2, like that. All of these elements and compounds are not chemically bonded to each other. They can be separated out, and that's why they are a mixture. Okay, so how they get separated is using physical techniques. So physical techniques. So this means that we're just using methods to separate out the elements and compounds. We're not breaking any bonds here. We're not chemically changing any of the substances into anything else. It is literally just finding a way to separate those out, whether it be separate out the larger ones in filter paper, whether it be evaporating water. We're not actually chemically changing any of those structures or breaking any bonds. Okay, so the first one I want to look at is chromatography. So chromatography is usually used to separate out things like dyes, just different colours really, dyes, colours. And what you use is chromatography paper. So here's my chromatography paper. You may have done this practical before. So this is my beaker full of a solvent. It might be just water. So what you do is you draw a pencil line at the bottom of your chromatography paper like that, and you get your spot of ink or dye and you place it on that line like that. Then your beaker should have solvent below that line. So let's say it's sitting in some water below the pencil line that you've made. Okay, and what's going to happen is the solvent is going to be carried up the chromatography paper, and it's going to take the dot, the different colours, it's going to separate out whatever different colours this dot is made of up the paper. And as that happens, you will get different dots. It doesn't really matter how many, sometimes it's 2, sometimes it's 3, sometimes it's even more, depends how many colours make up that one dye, that dot. And then your solvent will keep going, and you have to draw a pencil line as to where your solvent stopped. So this is the point at which you took the chromatography paper out of the beaker and you drew a pencil line. So in order to work out the RF value, which is called the retention factor, the RF value is really simple. So you just measure the distance between the pencil line, the dot, and the solvent pencil line at the top. So that distance, let's say in centimetres. Then you measure the distance between whichever dot you're trying to find the RF value for. So let's say I'm trying to find it out for this one. You measure this distance, the distance it's travelled, again in centimetres, you just use your ruler. So the equation is distance travelled by dot divided by distance travelled by solvent, and that's it. There's no units for this. RF will just be a value, just a number with no units. Okay, so it's really important that you use pencil here when you're drawing on your lines, because if you use ink or if you use pen, that will separate out as well, and that will ruin your whole experiment. So it's very, very important you use pencil, which doesn't separate out as the solvent is being carried up. Okay, so that's chromatography. Let's have a look at filtration. So filtration is just using filter paper. And what this does, it separates out insoluble solids, spelled that right, soluble solids from liquids. So for example, you can separate out rocks and salt and sand using filter paper. So what you could do is, you've got a beaker here, you've got your funnel, and you place filter paper in the top like that. You pour in, let's say I've got a solution of rocks and water. Let's just go with rocks and water. Okay, so your rocks and water are poured in here. What's going to happen? Your rocks are going to stay here because they can't get through. The funnel is too slim for the rocks to pass through. So there's all my water dripping through, and there's all my rocks collected at the top in the filter paper. So insoluble means a substance that hasn't dissolved in that liquid. So for instance, rocks do not dissolve in liquids, therefore we can use filtration. Okay, next one, nice and easy. Let's do evaporation. So evaporation, let's say we've got salt and water solution. You get an evaporating dish, you've got your Bunsen burner here, you heat up the salty water, and what's going to happen? Water evaporates, and evaporation just means turns from a liquid to a gas because of the heat energy, and the salt will be left in the evaporating dish, and that's how you separate out water and salt. Okay, last one then is distillation. So distillation is using a condenser. So here is my conical flask. I'm going to try and draw this the best I can. So this is seawater, and seawater contains salt and water. Okay, so we want to separate out the salt and water. So here I've got my bung, I've got my thermometer, and attached to this conical flask is a condenser, and a condenser basically cools down the gas, which I'll explain in a moment. Just think condensation. Condensation is where a gas turns into a liquid, and that's exactly what's going to happen here. This is a really bad diagram, but I hope you're getting the idea. Okay, so let me just talk through it. So here is my heat. Okay, here's my Bunsen burner. My salt water is sitting here, and what happens is the water evaporates. So water evaporates, it starts to rise because it's now less dense. Starts to rise, travels through this. Now the condenser has cold water running through it on both sides like this. It's usually shown like this, where the cold water goes in, cold water in, and cold water out. This is to just keep the whole condenser cold, basically. But none of that cold water is going to pass through where the gas is passing through. It's just making the whole thing cold. So, okay, my water has evaporated. It's turned into a gas. It's now travelling down the condenser, and because it's cold, it cools that gas down, and the gas then turns into a liquid, back to a liquid, and we collect pure water in the beaker, and the salt is left there in the conical flask. And that's all distillation is. It's just separating out soluble solids, because salt does dissolve in water, soluble solids in a liquid, separating them out back into the solid and into the liquid. Okay, so we will have a look at fractional distillation in another video when we focus on crude oil. But for now, I hope that was an okay video for you. Sorry about the diagrams, but I hope my explanations were okay for you. All right then, thank you, bye.